The purpose of this video is to just try to clarify some of the common mistakes that students make when they're working with their exponents. As you can see, we have some different types of problems here. We have a group to a power. We also have another group to a power, but this group is separated by addition. Third example, you have a fraction with some powers, and in the fourth example, you also have a fraction with a negative exponent. So we're just going to go over each of these quickly, and I'll try to identify what the common errors are. So as we look at this first example, we see that we have all multiplication inside here, and it's to a power. And so we know that one of our exponent properties is if you have a power to a power, you can multiply those things. And so what students tend to do, and so I'll write the mistakes in red here, students tend to start with the y, and they said that's y to the 9th, and then they have x to the 6th, which would be correct by using your properties. But then what they do is they do 4 times 3, and it's because you see a 4 here, and they're just so used to multiplying that they put a 12 down, which that would be definitely incorrect. The idea is that you are cubing this, and the 4 has a power of 1, so it's really, instead of 4 times 3, it is actually 4 to the 3rd, and then you have x squared times 3, and y to the 3rd times 3. And that's how we end up with our final answer of 64, x to the 6th, y to the 9th. So students tend to do well with the powers, but just be careful with that 64 out front. And that's the very first big mistake. Now, another very similar mistake is if you have 3x plus 2. Unfortunately, what students try to do is use the same concept that we had over here where you do the power of the power, and they just start squaring both parts because they think you can do that. And so the unfortunate mistake is that students would write 9x squared plus 4. And to be honest, if you want to frustrate any math teacher, it's go ahead and put this down on a piece of paper because that will get them every single time. Because really, of course, we know that squaring something is really 3x plus 2 times another 3x plus 2. And so there you'd use your generic rectangle or foil pattern, however you choose to go about doing it, and you would end up with 9x squared, but then it's going to be plus 12x because you have 6x from this 2 times 3x, and another 6x from that 3x times 2, and then you have a plus 4. And so you do not get to distribute a power when you have addition. Addition does not follow your same power properties that this multiplication did over here. The third common mistake has to do when students are dividing fractions. And so again, students are pretty good at the actual exponent part of this, because where students would start, they say, well, this y squared over y part is equal to just a y on the top, and the x to the 5th over the x to the 3rd part is then equal to the x to the 2nd power, x squared, because that's 5 minus 3. But then what they do is they do 5 minus 15 or something to that effect, where they might either say that you have a 10 on the bottom because 15 minus 5, or they might say you have a negative 5 on top, which is a little more rare, but all of those are wrong, right? Because when you have this 5 over 15, that does not follow your exponent properties because 5 and 15 are not exponents. They're just multiples. And so these would be two major mistakes that students make. And so when you are simplifying this, again, the power part students tend to do a little bit better with. You have a y on top and you have an x squared on top because of those power properties, but you have to then reduce the 5 over 15 part as if it was a fraction, and you'd have a 1 over 3. And your final answer would be x squared y all over 3. And so be careful with division. This is 5 over 15. And they follow your rules of fractions versus the rules of our exponents. Our final example is a little more simple. It's just having to do with this exponent of negative 4 here. And some students struggle with how to rewrite this because we do hopefully recall that if you have a negative exponent that you can, quote, flip it up or flip down, depending on what side it's on. So we would want to move this x to the negative 4th. But on occasion, what students will accidentally do or do without thinking, they'll move everything there, right? And they'll write 3y times 2x to the positive 4 because they think that they're moving this negative 4 up to the top. But this x to the negative 4, or the negative 4 itself, is only the power of x, not the power of 2. So that's why this is incorrect, and you can't do it that way. What you really want to do is just move the x to the negative 4th part up to the top. So it's the x to the negative fourth alone that moves up, because that only is, the x is the only thing that has that power. So your final answer would be 3y x to the positive 4 all over 2. And that would be the correct answer for these problems. So if you can avoid these common mistakes, especially the power, and the reducing these fractions, you will put yourself in a much better position to simplify these exponent problems.